Hello student, welcome to all of you in the next physics lecture. Now I have to see here the derivation for the angle of banking, and the diagram is just like here. This question is like this: derive the expression for angle of banking when the vehicle is moves along with a curved bank road, neglecting the friction. When there is this neglect, friction should be neglected, then what is the formula for the angle of banking, or what is the speed for the car with which can be safely driven? So this is for the a diagram for the angle of banking. For the speed of this of the car can be safely driven, the speed we have to find out here. The diagram is just like here. Suppose that this car is moves along with the horizontal curve road surface, then m is the mass of that car, r is the radius of this curve path. This is the curve path, then r is its radius, v is the speed of the car, and theta is the angle of banking here. Okay. When this car is moves along with the horizontal curve road, then there are the two types of the forces are acting on this car, and these two forces are nothing but the weight mg of that car, which is the vertically downward direction. There are the two types of the forces, and one force is just like the weight of the car mg, and which can be directed vertically downward direction. Okay. And second one is the a normal reaction between the car and the road surface. That means when the car take the turns at that time, the first force is its weight mg, which can be act vertically downward, and second one is the a normal reaction in between the car and the this road surface, which can take the turns at that time. Okay. And when this normal reaction, which can be resolved into the two components, this is the here normal reaction, which can be the resolved into the two components, and these two components are horizontal component n sine theta as shown in figure, and vertical component, this is the n cos theta. Normal reaction which can be resolved into the two components, horizontal component n sine theta and vertical component n cos theta as shown in figure. But again, this horizontal component which can be directed towards the a center of the circular path, center of the curve path, this like just like, because the car is take the turns at that time, this horizontal component which can be directed along the centripetal force, that means directed towards the center of the circular path, which is acts as a centripetal force, because we know that the force acted upon the radius along the radius towards the center of the circle, this is nothing but the centripetal force. And so that this horizontal component which can be directed along the center of the circular path, so that it acts as a centripetal force. Therefore we can write here the n sine theta, see here, n sine theta is equal to mv square upon r. This horizontal component directed towards the center of the circular path acts as a centripetal force, so that we can write here n sine theta is equal to mv square upon r. Suppose this is the equation number 1. Okay. Now this vertical component n cos theta as shown in figure, this n cos theta, which is balanced by the weight mg act vertically downward direction. This is upward, this is downward, so that this n cos theta, this is the vertical component which can be balanced by the weight mg of that car, so that we can write here n cos theta is equal to weight mg, because this vertical component n cos theta which is balanced by the weight mg, so that we can write here n cos theta is equal to mg like this. This n cos theta is equal to this weight mg, and this is the equation number 2. Then we have to take the ratio of this equation 1 and 2. Okay. First equation is what? N sine theta is equal to mv square upon r. This is the horizontal component directed towards the center of the curve path, so that acts as a centripetal force. And second one is the this vertical component n cos theta, which is balanced by the weight mg downward direction, and so that n cos theta is equal to mg. This is the equation number 2. Taking the this ratio of equation 1 and 2, that means we have to write here n sine theta upon n cos theta is equal to mv square upon r upon mg. Then you know that this n should be cancelled, and sine upon cos, this is nothing but what? Tan theta. And therefore this tan theta, this is nothing but tan theta is equal to v square upon rg. Okay, this tan theta is equal to v square upon rg, or v square is equal to rg tan theta. Okay, or v is equal to under root rg tan theta. And this is the expression for the maximum speed with which the car can be safely driven, and with the radius r and the angle of banking theta. From this equation, it is also clear that the speed of the car does not depends upon its mass. Speed of the car does not depends upon its mass. It depends upon only its radius of curve path and angle of banking, and does not depends upon its mass. This is the very simple derivation for the speed of the car which can be safely driven, neglecting the friction. But we have to consider here, suppose the should be the need for the lower and the upper speed for the limit for the vehicles the moving the bank road. Then what is the expression for it? We have to see here. Okay, there are the two diagram, that is the bank road for the lower speed limit and the bank road for the upper speed limit. These two diagram, from these two diagram we can find out the expression for the this that is the speed of the car. First of all, we have to see here the banking of road, but there is neglecting the friction, and that formula is also very important. Tan theta is equal to v square upon rg. But if you have to consider the what is the need for the lower and the upper speed limit for the vehicle moving on the bank road, and derive the expression for it, then we have to consider this two diagram for the lower speed limit and the upper speed limit. There should be the mathematical derivation you can be see here. If the vehicle is running, suppose the exactly the speed, that is the vs is equal to rg tan theta, and the speed of this car which is suppose the less than this factor rg tan theta, that is the component of the forces, that is the static friction between the road and the tires of the car, then we can write for the speed which is less than this under root rg tan theta. Suppose for the speed we have to take here the speed v1, that is the speed for the lower limit, that is the v1 is less than rg tan theta. Then this component n sine theta which is the greater than the centrifugal force mv1 square upon r, and so that we can write here mv1 square upon r is less than n sine theta. And in this case the direction of the force of the static friction fs means what? The static friction, that is the force of static friction, and which is the between the road and the tires. Okay, and which is directed along the inclination of the this road upward side, and so that these two forces take care of the necessary centripetal force, and this centripetal force mv1 square upon r is equal to this n sine theta, this component n sine theta, and which is nothing but less than this fs cos theta. And so that since centripetal force which is given by using this formula, see here, mv1 square upon r is equal to n sine theta minus fs cos theta. This is the equation number 1. Okay, then this vertical component n cos theta and fs sin theta which is balanced by the weight mg, and therefore this mg is equal to n cos theta plus fs sin theta. See here this in diagram, here is mv1 square, this is nothing but the weight mg, and which can be the balanced by this n cos theta. Okay, and the fs sin theta, this is the static friction, force of static friction, and this angle between sine angle between them, mg is equal to n cos theta plus fs sin theta, and centripetal force less than n sin theta which can be given by the static friction that is between the road and the car is directed along the inclination of the road upwards its horizontal component fs cos theta, and it should be, we can write m v1 square upon r is equal to n sin theta minus fs cos theta. And the vertical component weight mg, which can be balanced by the n cos theta plus fs sin theta. And then we have to take the ratio of this equation 1 and 2. Then we have to write directly here, but if you have to got this solution, then here is this solution part, dividing this equation 1 and 2. Then mv square upon r upon mg, then get cancelled, only simply v1 square upon rg, then n sin theta minus this fs, you know that in 11th standard fs is equal to mu s upon mu s into n, because we know that static friction, coefficient of static friction is equal to what? The fs upon n. Therefore fs is equal to mu s n, substituting here mu s n cos theta, mu s n sin theta. Okay, and dividing above this equation by n cos theta, then we get this. Okay, sin upon cos, tan theta. Here also sin cos cancel, here cos cancel, and sin upon cos tan. Therefore v1 square upon rg is equal to tan theta minus mu s upon 1 plus mu s tan theta. बरेचसे विद्यार्थी विचारतात, सर हे कुठून आलं इक्वेशन? तर आपल्या पुस्तकामध्ये सॉल्व्ह करून दिलेलं नाही. टेकिंग द इक्वेशन 1 अँड 2, आपल्या परीक्षेमध्ये सुद्धा एवढं सॉल्व्ह करायला वेळ नसतो. आपण डायरेक्ट लिहिलं तरी आपल्याला त्याचे मार्क्स मिळतात. पण तुम्हाला माहीत पाहिजे की हे V1 जे आहे मिनिमम स्पीड आहे ते कसं आलं, RG इंटू ब्रॅकेट टॅन थिटा मायनस म्यू एस अपॉन 1 प्लस म्यू एस टॅन थिटा. हे थोडंसं स्क्वेअर रूटमध्ये आहे, स्क्वेअर आहे तर स्क्वेअर रूट काढलं, त्यामुळे स्क्वेअर रूटमध्ये RG टॅन थिटा मायनस म्यू एस अपॉन 1 प्लस म्यू एस टॅन थिटा असं येतं. तर हे कसं येतं इथं बाजूला आपण दाखवलं पाहिजे. ह्या दोघांचा रेशो घेतला आणि या एफ एसबद्दल आपण म्यू एस एन असं लिहिलं आणि या इक्वेशनला आपण कशाने डिवाईड केलं, एन कॉस थिटाने डिवाईड केलं. हे एन कॉस थिटाने डिवाईड केलं सर्वांना माहिती आहे, साइन अपॉन कॉस टॅन, आणि म्हणून इथे V1 स्क्वेअर अपॉन RG टॅन थिटा मायनस म्यू एस अपॉन 1 प्लस म्यू एस टॅन थिटा. म्हणजे RG इकडे डिवाईड, इकडे आल्यावर काय होणार ते मल्टिप्लाय, आणि मग त्याचं स्क्वेअर रूट काढलं. V1 इज इक्वल टू अंडर रूट RG, हे RG इकडे आलं RG, आणि टॅन थिटा मायनस म्यू एस अपॉन 1 प्लस म्यू एस टॅन थिटा. हे असं इथं आलेलं आहे, सोडून दाखवलं आहे याच्यामध्ये, म्हणून ह्या मुद्दाम ह्या पुस्तकात मी तुम्हाला हे दाखवलं आहे. आता असंच आपण सेकंड स्पीड जर घेतलं त्या ठिकाणी, हे आपण लेस दॅन RG टॅन थिटा घेतलं. इफ यू हॅव टू टेक फॉर सेकंडली स्पीड V2 म्हटलं आपण त्याला, V2 विच इज ग्रेटर दॅन अंडर रूट RG टॅन थिटा. RG टॅन थिटा आपण याच्यापेक्षा ग्रेटर घेतलं. मग त्याची डायग्रॅम अशी येईल पहा. इथे हा जो कंपोनंट आहे साइन थिटा, तर इथे आपला एफ एस कॉस थिटा, इथे एम जी आहे, इथे एम एन साइन थिटा येतो. म्हणजे या बाजूला या ठिकाणी याचं या ठिकाणी एफ एस हा कॉस थिटा येतो पहा. याच्या इथे या बाजूला आला, तो या बाजूला आला, बिकॉज इट V2 इज ग्रेटर दॅन RG टॅन थिटा. मग त्यासाठी जो काही सेंट्रिफ्युगल फोर्स असेल तो MV2 स्क्वेअर अपॉन R असेल, विच इज ग्रेटर दॅन एन साइन थिटा. अगोदरच्या सारखंच MV1 स्क्वेअर अपॉन R लेस दॅन एन साइन थिटा. इथे फक्त काय दिलं मी, ग्रेटर दॅन एन साइन थिटा. मग इथे आपण मायनस काय केला होता, एफ एस हा ग्रेटर असल्या कारणानं इथे आपण प्लस एफ एस कॉस थिटा करणार पहा. MV2 स्क्वेअर अपॉन R इज इक्वल टू एन साइन थिटा, मायनस होतं लेस दॅनच्या वेळेस, आता ग्रेटर दॅनच्या वेळेस आपण काय घेतलं, प्लस एफ एस कॉस थिटा. ओके, मग पुढे हा जो व्हर्टिकल कॉम्पोनंट आहे एन कॉस थिटा, तो सेम बॅलन्स्ड बाय द एफ एस साइन थिटा आणि एम जी. मग तसंच आपण लिहिलं पाहिजे, काय एन कॉस थिटा इज इक्वल टू दिस एफ एस साइन थिटा प्लस एम जी, किंवा एम जी इज इक्वल टू एन कॉस थिटा मायनस एफ एन साइन थिटा. इथे फक्त प्लस होता, इथे तो मायनस आला. एम जी इज इक्वल टू एन कॉस थिटा मायनस एफ एन साइन थिटा. आणि मग हे मॅक्सिमम पॉसिबल स्पीड आहे, म्हणून याला मॅक्सिमम इक्वल टू म्यू एस एन एन, याच्याऐवजी आपण व्हॅल्यू टाकू शकतो. पुन्हा अगोदरच्या सारखं टेकिंग द इक्वेशन 3 अँड 4, ह्या 3 अँड 4चं जर आपण इक्वेशन घेतलं तर पुन्हा आपल्याला हे MV2 स्क्वेअर अपॉन R अपॉन एम जी, एम एम कॅन्सल होईल, V2 स्क्वेअर अपॉन R येईल, आणि इकडे आपण पुन्हा डिवाइड बाय दिस आपण त्याला एन साइन थिटाने जर एन कॉस थिटाने आपण जर त्याला डिवाइड केलं तर ते पुन्हा तुम्हाला इक्वेशन जे मिळणार आहे ते असं असणार आहे पहा. V2 मॅक्सिमम इज इक्वल टू RG टॅन थिटा प्लस म्यू एस अपॉन 1 मायनस म्यू एस टॅन थिटा. हे तुम्हाला अशा प्रकारचं इक्वेशन त्या ठिकाणी मिळतं लक्षामध्ये. तर दिस इज द एक्सप्रेशन फॉर द नीड फॉर लोअर अँड अप्पर स्पीड ऑफ लिमिट फॉर द व्हेकल मुव्हिंग ऑन अ बँक रोड, अँड This is the necessary expression for this. If you have to understand this, okay, we have to stop here.